Hi everyone, today in Integrated Math 1, we're going to go over Chapter 11, Lesson 2. Here are your objectives. Make sure you write them down in your notes. Alright, let's go over our postulate. Corresponding angles postulate. If two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Alright, so remember corresponding angles, we have to have two parallel lines. In this case, here they are. So this line and this line. Then they have to be cut by a transversal, which is this line here. We can have multiple corresponding angles. In this case, here's our first pair. The way I remember this one is that the angles have to be congruent. This one, it basically slides down here and it'll match up perfectly because they are congruent. And as you can see that right there, they slide back and forth. So here's another pair. And it's going to be the same idea. It would slide up and we can see that it's congruent as well. We have another one here and it matches up perfectly when it slides up. Our fourth one, it slides and it's congruent as well. And if we were to change any of these, so I'm going to move this around a little, put that up a little, and let's go back to, let's say, our first pair. It's still going to match up perfectly because they are corresponding angles, which means they are also congruent. Alright, next we have theorems that apply with parallel lines and angle pairs. The first one says, our first one is alternate interior angle theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. So remember, alternate interior. So first of all, they have to be inside angles and they have to be on opposite sides. So one's going to be on the left and one's going to be on the right. Or it looks like in our case, one's going to be up top and one's going to be on the bottom. But needless to say, they are on opposite sides. So our first example is angle 1 and angle 3, which are congruent, and angle 2 and angle 4 are also congruent. Then we have consecutive interior angle theorem. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles are supplementary. Remember, when we're talking about supplementary, that means when you add both of those angles together, they're going to add up to be 180 degrees. So angle 1 and angle 4 add up to be 180 degrees. And angle 3 and angle 4 add up to be 180 degrees. They're interior angles and they're consecutive. I remember this one as it kind of makes a C depending on how you're looking at it. This way it would be kind of a sideways C. And in this case, it would be right there as well, to help you remember. It has to be inside. Alternate exterior angle theorem. If two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. So exterior angles, and they have to be alternate from each other, opposite sides. So angle 6 and angle 8, those are congruent. And angle 5 and angle 7 are congruent as well. Alright, let's go over these. So corresponding, remember these have to be congruent, and because they are the same color shown here, means that no matter how we change it, even if we're changing the angle, they're still going to be exactly the same. Alternate interior angles, same thing, they're on opposite sides inside, but they are going to be the same measurement. And alternate exterior is the same idea. If I'm changing them, oops, the angle measurements are still going to be congruent. However, when we get to same side interior angles, notice what happens here is that they are not congruent, but they do kind of form that C. So there's a C here, and there's a C here that we talked about. but they are not congruent, but they will add up to be 180 degrees. Then we have the same side exterior angles, same side, but they're on the outside. And these ones, notice they are not congruent, but what we can see is that they will also form 180 degrees. Next we have perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So as you can see, remember this symbol means parallel. So if line A is parallel to line B and line A is perpendicular, that's what this symbol means, to line T, then line B is perpendicular to line T. And notice they're making those 90-degree angles. And that's it.